Ever wondered how your computer knows which network it's on, or how IP addresses are structured? The secret lies in bits, bytes, and network classes. In this video, we'll break down the basics of binary, how IP addresses are divided into network and host parts, and why understanding network classes is crucial for networking, whether you're studying for a certification or just curious about how networks work. This is your ultimate guide to mastering IP addressing. Ready to decode the secrets of networking? Let's dive in.
In this course, we will start by seeing the difference between 1 bit and 1 byte. A bit is the basic element with which the computer works. Its value is either 1 or 0. We can translate that by on or off, or true or false. The word bit is the contraction of the word binary digit. And a byte is a set of 8 bytes, like the ones we just saw above. Now let's talk about the network address. The network address is a unique identification of the network. Each device in the same subnet shares this network address in its IP address. For example, in addresses 192.168.1.0.0.1, 2, 3, the part 192.168.1.0.0 corresponds to the network address, and the 1, 2, and 3 are the hosts. The IP address tells us which subnet they are in. The network address must be the same for all hosts, and the host part must be unique. Each subnet must have a network address. When the Internet was invented, they created different classes of networks, each of a different size. Class A goes from network 0 to 127, Class B from network 128 to 191, Class C from 192 to 223, Class D, which is for multicast traffic, ranges from 224 to 239, and Class E is a reserved class, which goes from 240 to 255. These network classes are to be learned by heart, because the exam has a lot of questions on it. Let's see more of the different classes. A Class A network has 1 byte reserved for the network address, and the other 3 bytes are left for hosts. This means that we only have a few networks, and each network can have a lot of hosts. If we look at the address IP102012, the 10 is the network address, and the 2012 is the host address. All machines on this same subnet will have the network address 10. A Class B network has 2 bytes reserved for the network address, and the 2 other bytes are reserved for hosts. This means that we have more networks, but fewer hosts per network than Class A. For example, in address 172.168.1.6.1.2, the network address is 172.1.6, and the address host is 1.2. And a Class C network has 3 bytes reserved for the network address, and 1 byte is left for the host part. Here we have a lot of networks, but only a few hosts per network. In the address 192.168.1.2, the network address is 192.168.1, and the host will be known with the 2.